Hello everyone. Today we will be discussing one of the problem which we can solve using backtracking. The problem is you have been given the numbers in an array and sum as a target. You have to achieve this sum using these numbers. Numbers can be duplicate. Like if I'll show you the output should be the numbers can be duplicate. You have to find out the number of subsets. How many subsets are there? Achieve this sum. We can use the same number multiple times, like 1 1 2. So you have to find out all the subsets. So what would be your approach? Just give a pause for 2 minutes and think about it. So to solve this kind of problems, always you have to go with backtracking. How you are solving in your mind these problems? Maybe you will take 1 1 1 as a 4. This is the one kind of subset. For another subset, what you are trying, you will add 1 1 and 2. It's a kind of subset. So what basically you are trying to do, you are back stepping 2 steps and trying with other number. Then you are back stepping 3 numbers and trying with 3 1 3. So you are just back stepping those things. So here as well, you are back stepping. First you choose 1 1 1 1, then 1 3 1 1 2. Then again you are choosing 2 and 2, and 2 and 2, 2 plus 3 is not possible. So you are just removing those elements. 2 and 4 is not. So just backtracking. You are just backstepping and trying other solution. You are trying, you are going to the depth, again come back and trying with the other kind of subsets. So if you feel where you have to backstep and change the approach, always go with backtracking. That's the perfect algorithm to solve these kind of problems. Okay. So one more thing, backtracking works on the principle of recursion. So if you don't know recursion, please uh, find out some video for recursion and come back. So recursion works on a two, I can say in a 2 steps. First, you have to prepare the base case when the problem should end, and second step, you have to call the same method in a recursion. But in backtracking, you have to call the same method, but you have to backtrack. Like whatever step you have executed, you have to just come back to the step and execute again. So we'll see step by step in this problem how are we going to solve these kind of problems. So just create a method. You have to find out all the subsets, so it's better create list of list, and it would be integer. Okay, we have created list of list where we can have our output. So directly we can create, no need to create, directly we can give get all subsets. uh, what are the inputs we have to send? That you have to prepare as a list. First thing, you have to send the numbers which we are getting. So numbers, okay. Second things, you have to send the sum. What are the sum we are trying to achieve? Next thing, we can send as a result. So we'll create one variable, or we can send result as a 0, because we have to write the base steps where you want to stop. When result is same as a sum, we can stop. We can see in a base case while writing. So we need one result as a variable, or we can point out as a 0. We need an index for tracking purpose. So index, okay, we'll create here, otherwise we'll get confused. So For tracking purpose, this is the result, this is the index. What else you needed? You need one kind of list of list to store the element. So I'll create list of integer where we'll store the elements. So subset I can say is a set. We can say set. Create one more list where list of subsets we can store. What's the wrong here? Okay. Okay. We'll explain each keyword why we have created these many variables while writing the base case. Okay. So this is, this is the just we have to get the numbers. This is the sum which we're trying to achieve. Result where we'll store our result to make the base case. So let me write the base case. What is the base case? Where we want to end our problem, end our case. So if so in a result, we'll add one by one element. So we'll add first element, then we'll add again first. When it will come as a four, that is the one kind of subset we have that we can add in a subset. So when result becomes equal to sum, then we will get one kind of subset. So we'll add in a subset, I can say all subset. This should be new of array list. Or maybe I can say list of list. Okay. This is a list only, I can say. Or here we can pass as a list. Okay. This is the list of list where we have to store all the subsets. Okay. So this is the base case we have written. Uh, if it is equal in all subset, what we can do, we can add set. What is the list we have given as a? Here we can give set. Not always we can get as a sum, we can get more than that. If we are trying to add 1 and 3, we will get 5. So it's a more than or maybe equal to sum, then we'll come in this case. We'll add one more condition. If result is equal to sum, then we are trying to add the subset. Otherwise, we'll return the same subset which we have. Okay, we will not add, we'll return all subset. We'll return the, so if it's not sum, if it's greater than, we'll return the subsets. Okay, so this is the base case we have written. Rather than base case, what we have to do? We have to iterate those numbers. So first we'll iterate those numbers. We'll provide the index, whatever index is start from 0 because and it will go till numbers length. Now actual backtracking will now we have to call the same method. But before that, In this result, let me add, in this as result, let me add the numbers, result plus numbers of I. So we'll try to keep adding. Once it become as a sum, we'll break. We just return. If you're saying when result become as a sum, we will break it. Or that this is our base case. This is the actual backtracking we are putting. So we have added, we are just added in a result first number. Then what we have to do next? We'll call the same method. While adding, we'll call the same method. So I'll call get result subset. We'll call in the same manners. Sum. Then we'll result. We'll send index. Index will send as I, because whatever index will become is I. We can send and set. So same. Yeah. So once number is there, we have to add in a set as well, because if that number is there, we have to add in a set. So it will prepare what kind of set. These are the one kind of set. So set and subset, all subset. Is there anything we need to pass? Nothing. So this is just kind of recursion we are doing. Now it will keep going. Then it will work 1 1 1. Then it will work 2 2. It won't come back. So once iteration go like this, the index will be changing. So what you have to do, and these numbers keep trying to add. Whatever steps for a back stepping, whatever steps we have performed before calling the method, same step you have to perform in a reverse order. That's called the backtracking. Suppose for a recursion, we are adding these numbers. Then for backtrack, we have to subtract these number from subset. So if you added till here, you have to subtract this number, last numbers. Come here, these two. And if you want to go more back, then subtract this number. It will become 1. So these we are adding here. So what we did, we added in a result numbers. So we'll remove those numbers from result, because if it is, if it is a sum, then it will be added in a subset. If it is a more than sum, then same subset will be returning, but we have to decrease that number from result. Otherwise, in other case, it will keep trying to add. We are not backstepping or backtracking. And second thing, from set, you have to remove the last element. How can you remove the last element? You can go to the numbers.length, or maybe subset. You have to remove set.size -1. So it's the last number, it can be removed. I don't feel anything is left out. We are just backtracking. How it works, let me explain as well. Oh, this we are closing. Now we have forgot to return subset. Okay. Okay. So we are just entering these numbers. So here the number has same. Then we are running. So let me write down the numbers. It will be very easy for to explain. So these are the numbers. So first time the index will be 0. 1 will come. It will add in a last 1. It will be like 1. Then again it will go call all subsets. Numbers would be same. Sum would be same. Result will become as a 1, because we have already added. Index will be same. Set. They have added one number, so set will become 1. Subset always empty. Again the index would be 0, because we are not changing the index. So 1 1 1, it will go like this. Once it will 4, it will come here, it will add in a subset. Subset will become 1, and again it will come back. Now it will go here. Once subset is completed, it will remove the last element. It will become like this. In a set also it will remove. From set also it will remove. The result will become, set will become this one, and result will become as a 3 in that case. And for second call it will 2, and it will become like this. So it will perform on the stack. It will perform on a stack frame. You can put the debug point here and just see one by one call. You will understand better how backtrack will work. So let it run. Is it working or not? Some problem. I didn't see what was the problem. Okay, I have not printed anything. Yeah, okay. Let me print list of integer or list. No, it should work. If you print the set by set, yeah. So if you can see 111, 112, 13, 22, and 4. These are the valid subsets. You can return the list of size, anything you can return. Let me change the output. Let me give 6. You see. So for 6, it worked perfectly fine. I hope you understood the problem and thank you.